Bismillah. Hello, welcome back. In this video lecture, we shall discuss some preliminary image processing questions and we shall see this in MATLAB. The first question, consider the image cell.diff. What are the dimensions of the image? That is, what is the row and column size? Okay, the simple way is, I will take a variable im is equal to im read. The image which is asked is cell.diff, and if I put a semicolon to suppress the output. Therefore, one way to find the size of the image is use the workspace. You can find that 159 rows and 191 columns, or you double click this one. Here you can find the size of the image also. It has 159 rows and likewise it has 191 columns. Right, this is one way. The other way, simpler way, is you can give the command imf_info, file information, this cell.diff. Right, this gives a long descriptive details which tells the format of the image, tagged information file. It has 191 columns and 159 rows, and the values are represented by 8-bit, and the type is grayscale. So this is second way. The third way is we can give the command whose. This also tells me the size of the image. If you multiply 159 by 191, you will get this many bytes it takes. This one is the what is the type, what is the class. It is an unsigned integer of type 8. Right, those many ways we can find out the size of the image. The second question is, how many pixels are there in the image? That is, pixels means you can find the rows and columns. As usual, here itself we can find this one. The size of the pixel value is, the number of pixels is 30,369. Or you can, in a vector r comma c, I can get the size of the image by size of im variable. This gives me number of rows and columns. Now I can multiply the two values by r multiplied by c. So this also gives me the same 30,369. Right, next question. What is the darkest and lightest gray level values? Yes, the lightest value, darkest value is nothing but what is the minimum value and maximum value. So the minimum value is 28, the maximum value is 212. Here itself you can find out. Or in the image you can see that the minimum value and maximum value, what these values represents, they represent values from 0 to 255. So 0 means black and 255 means it is white. The in between values, all these things are the different levels of gray level. Right, from the workspace itself I can find the minimum maximum value, or I can find the minimum value by the function min of im, find the minimum value of the entire image. So this also gives me the same minimum value equal to 28. The same way I can find the maximum value in the image is im. This colon represents the entire image, that is all rows and columns. The maximum value is equal to 212. Right, the next question. What are the gray level intensity values? That what is the gray level intensity value at row number 23, column 44. Row 23, column 44. So we can find, I can take the image is nothing but a matrix, there row 23, therefore this is the row number 23, and a column number 44 I want, therefore this is the column number 44. That is what is the gray level value at this row comma column. So the value is equal to 79. Or by a command itself I can find im of 23rd row and is it 23rd row? Yes, 23rd row and 44th column. 44th column. Therefore, this also gives me the same value, 79. Right, next one is how many pixels have grayscale intensity of value 124? That is, we want to find the count of the pixels which has the value of 124. How many pixels are there with the values 124? So here what we can do is we can plot, the simple way is we can plot a histogram IM hist for the image IM. So this gives me a histogram. The histogram will come, so that see that the axes are not fitted because the image is little bit high. Therefore what I will do is I will use the command axis, and this one is auto. Right now if I see the histogram, you can find this one. This pixel value, this represents, see that the 0 represents black and 255 represents the white, and the histogram represents how many pixel values are like this. I mean, what is the count of each pixel value. Instead of axis auto, I will say axis fit, not axis fit. Yes, here between 100 to 124 I can use the data cursor and I can place it here. So this is x represents the pixel and y represents the count. We want 124. We want the, what is the x value? 124. Therefore see this, the x value 124 appears 522 times in this image. The intensity value x equal to, 124 appears how many times? 522 times. We can put the image histogram, and from there we can use the data cursor and we can find the count of how many times a pixel value is present. Otherwise we can use the logical operation. I will take some variable x is equal to, then I will use from the image, I compare how many values are with 124. This will give me a long list of values which are equal to 124. That is, otherwise I will give an example. Suppose if A is a vector where it is say 1 2 1 2 3 4 3. This is a simple vector. And suppose if I want that something B is equal to, wherever A is equal to 3, then corresponding terms alone I will get 1. See that this is not 3, therefore it is 0. Therefore all these values are 0. All these values are not equal to 3, therefore they are 0. And this value is 3, therefore it is 1. This value is 3, it is 1. Therefore I can count how many values are there just by saying sum of B. Therefore there are 2 values. The same concept we can apply, and I can take x is equal to, otherwise directly I can find sum of, from the image I compare which value are equal to 124. See that I am comparing with 124. Therefore this gives me all the values which are, so this has given me sum of, not this way. I think I could have done the other way around. I could have taken a vector, so I could take x is equal to, and from the image whichever values are equal to 124. Alright, now x has become like this. It is a logical operation. Now from there we can find the sum of x of all values. Yes, this gives me 124. That means 522, the what value we got in the histogram. Right, the next one, which grayscale intensity has the most pixel value? Most one, that is which pixel value is repeated many times. So I can use again the image histogram and I can apply the image. Right, here since it is exceeding, I can take axis is equal to auto, and now you find it. See that if I enlarge this one, see this pixel is repeated many times, therefore I can use the data cursor. We can find out here, you can find that this pixel value, that is x 119, occurs 4023 times. So the pixel x is equal to 119 occurs how many times? 4023 times. Yes, this one is the most repeated value. From histogram itself we can find. Otherwise we can use a command. Suppose if I take mode of I take a vector 1, 2, 3, 2, 2, 2. Now this will tell me which number is mostly repeated. Here you can see that the 2 is repeated 5 times. Therefore the most repeated number is 2. Likewise, I can find the mode in the image. This may give me an error because the argument required by mode is it should be double, but our image is only unsigned integer. So temporarily we can change from image, I can change to and this one double of image. Alright. Now what was the mode in the this one? In mode, this one double, double. So this will give me, I could have double of all the values. Yes, 119 is the pixel value which is repeated many times. The same answer what we got in image histogram. IM hist and IM. The most repeated value was 119. I use access auto. 119 was the number. So here you can check it out. You can use the data cursor, check it out. 119 is the most repeated number. That is what we are getting here. Alright, the next question is create crop in image, that is 50 cross 50 pixel. I want to crop that, so this I close it. Now I can crop the image using the image tool itself, but let us take this one. IM2 is equal to, we shall take from the image, take from 1 to 50 rows, comma, take from 1 to 50 columns. 1 to 50 columns. Right, now from first 1 to 50 rows and 1 to 50 columns are taken, and so 50 by 50 matrix is assigned to IM2. I can show that image by show a function IM2. Now this one is the section of the image of the entire image. If you want to see the entire image, you can use figure show, and this is IM. So this is the entire image, and from this entire image I have cropped one image which is of 50 pixels. It is from here to here, so 50 pixels image is cropped. Okay, then let us go on to the next question. Right, question number 8 we shall continue in the next lecture. Thank you.